Hello and welcome to this MongoDB live presentation. We'll be covering how Apervita secures healthcare data using its deep encryption technology built on MongoDB's field-level encryption. We'll start with an introduction. We'll talk about what deep encryption and field-level encryption is. We'll then talk about why deep encryption is important and how Apervita is applying it to the health IT ecosystem. We'll talk about how we're pushing security forward and how deep encryption and field-level encryption work, and then we'll do a demonstration. I'm Mike Altman. I'm the Chief Technology Officer of Apervita, and Apervita is a trusted health IT cloud platform for collaboration. We recognize that there are multiple players in health IT, and they all need to collaborate and share data and insights among each other. And we're here to make that possible and do it in a secure way. Now, we're a MongoDB customer and have been for several years. We're deployed on Amazon Web Services using Atlas. We have multiple clusters and sharded configurations to handle all the operations we do. Last year, we joined the beta program of field-level encryption. And as an early adopter, we were able to apply it to become the first health IT company to deploy that field-level encryption technology within our deep encryption solution. So what is deep encryption and field-level encryption? Well, we're going to start with field-level encryption, and it is the foundation for our deep encryption solution. Field-level encryption was built into 4.2 and built into the driver and server. It goes beyond the traditional encryption at rest. It goes to protect the data at each field. Now, it uses JSON schema and the latest encryption protocols to give developers the control to implement their encryption solution. And it begins at the driver, which is very important because it encrypts the data before it arrives at the server. So the server itself cannot decrypt the data. Now, deep encryption uses field-level encryption, but we wanted to add some layers of control and granularity to the foundations that field-level encryption provides. We have multi-tenant collections, so we wanted to make sure we can encrypt the data within the collections with multiple keys. We want to provide the control of those keys and the control of security to our customers using bring your own key capabilities. And at the end of the day, we wanted to ensure that only authorized users of the platform can get appropriate access to the PHI. Now, who is Apervita, and why is this so important to us? Well, as you can see from the use cases displayed here, when it comes into the health IT realms of quality improvement, value-based contract administration, and interoperability, which is a recent new set of regulations, you need to exchange a lot of data. You need to share data. You need to share knowledge, and especially when it comes to analytic-backed applications. Whether you're building quality measures for regulatory submission or you're building quality measures to improve your patient outcomes, if you want to support interoperability and provide patient access to their data, if you want to improve the collaboration between insurance providers and doctors around value-based care, you want to make sure that the data is secure, and you want the owners of that data to feel that the data is secure and in control of that data. So security is number one, but sharing the data and protecting the data need to be equal in today's ecosystem. We can see from the current pandemic that the need to share data is growing more and more. But even beyond the pandemic, improving the quality of care and clinical decision support, streamlining our health IT processes are all important as we move forward. But there are a lot of barriers to sharing. The fear of data breaches, the cost of data breaches, the lack of ubiquitously adopted standards, and then the fear of losing control of data has all inhibited data sharing across the industry. There are also challenges to technology. While we want to connect the dots between availability and encryption and flexible data models and platform architecture, legacy technology is not designed to move this forward this fast. And as we move from on-prem to cloud technology, the paradigms have shifted, and we need to shift our security in the same way. So security in 2020 has shown us that early security practices are no longer enough. Encryption at rest, or full disk encryption, by itself no longer solves the security problem. We're no longer working in an on-premise and on-laptop environment. We've now moved our application to the cloud. We're now sharing our applications and our data through many different capabilities. We're now exposing our users through browsers instead of laptop applications. And so we need new technology to satisfy these new paradigms. Encrypting the disk does not protect against account breaches, which has a higher probability of happening in today's cloud provider environment. The everyday actors of database administration, support personnel, and even your IT partners now have access to the PHI. You can restrict some of the accounts to certain segments of PHI, but you are still allowing direct access to PHI to people who do not need the access to PHI. This is where deep encryption and field level encryption come in. It significantly reduces the risk of breaches by eliminating those everyday actors' access to the PHI. It eliminates full database breaches, and it also puts the control back into the hands of the data owners. Encryption at rest does not prevent account breaches. Everyday actors such as database administrators, support personnel, developers, and your IT partners all have accounts that give them access to PHI. And if one of those accounts is compromised, the database is compromised. We can put significant amounts of auditing and procedures and policies which do nothing but drive up the cost of security and still does not protect against that attack vector. And this is where deep encryption and field level encryption come in. We reduce the risk of breaches. We reduce the risk of full database breaches, and we put the control of data back into the hands of the data owners. So let's compare the old versus the new. Let's taking a look at full disk encryption. What happens is the data comes in and enters the database unencrypted. So even though the disk is encrypted, it's not really encrypted within the database, which means anybody with a database account can get access to that PHI data. Now, deep encryption changes that. It takes the data, encrypts it before it gets to the database. It encrypts it at the field level. And now that the database is encrypted within the database and the server itself cannot decrypt the PHI, anyone with an account cannot see the database, which means we can grant access to our database administrators. We can grant access to our developers, and we can be assured that they're not accessing the PHI. The only way to access the PHI is to decrypt the data through the platform with the appropriate keys as we're presenting it to the authorized users of the platform. So how did we get there? Well, let's start with our goals. Our number one goal is to reduce access to PHI only to authorized users of our platform, not just those who have account access to the database. We want to encrypt subsets of data with different keys to limit the amount of risk exposure of each population of data. And we want to provide those keys and the control of those keys to our customers so that they are still in control of the data, not the database in control of the data. We want to take this a step further, in fact. We want to encrypt the PHI with per-patient keys as a long-term strategy, and we're working towards that solution right now. But our current solution is based around the population's control. So each organization is assigned a master key. An organization can also bring multiple master keys through the bring your own key technology. That organization and that master key is then used to create population keys. So every population is encrypted independently. And those population keys are used to encrypt the PHI data. So to decrypt the data, one must have access to the master key, the database, and the Apervita software. This is a much higher level of security than offered by encryption at rest. So how does Apervita use field level encryption within our deep encryption solution? First of all, field level encryption provides a toolkit for encrypting the data on the client side before transmission to the database. There are two parts to this toolkit. First is JSON schema. The JSON schema is used to create a passive configuration so that every operation uses that configuration to automatically encrypt the data on the way into the database. In that JSON schema, you can specify which collections and which fields you want encrypted. And this pattern will suffice for a lot of use cases. But within deep encryption, we wanted to take a step forward. So the other part of the toolkit is the direct access to the encryption functionality itself. And it is a granular control that we wanted to use. So we used PyMongo, the Python MongoDB client, and we manually encrypted and decrypted within our solution. We also integrated AWS Key Manager, so we could provide the bring your own key capability. And within that PyMongo client, we used the classes of client encryption, and we used the methods of encrypt, decrypt, and create data keys in order to manually control where and when and how we wanted to encrypt and decrypt the data. So how does it all come together? Well, a FHIR document, which represents patient data, is sent to Apervita through our data loading APIs. We then reach out to the key manager, and we reach out to our population object to retrieve the keys. And using those keys, we encrypt the data and put that data into our multi-tenant sharded collection. Those keys are then removed from memory upon operation completion. When the data is requested for retrieval, we again reach out to the key manager for the master key, to the population key, and we decrypt the data. We throw the keys out of memory, and we return the data to the authorized requester. And that brings us to our demo. We begin our demo looking at the Apervita build screen within the Apervita platform. It shows two populations, one with the deep encryption flag on and one without the deep encryption flag. Now, it shows two populations inside of my MongoDB.live 2020 workspace. One is HIPAA compliant with the deep encryption on, and the other is our standard population with the HIPAA compliant flag, but without deep encryption. These two populations represent two segments of data within our multi-tenant collection. And what I'm going to do is start by dropping into the MongoDB shell to show that both of these collections are empty. And we will revisit the MongoDB shell later to show the difference between the encrypted and the non-deep encrypted population. What I'm going to do is drop into the MongoDB shell to show that the populations are empty. And we will come back later to the shell to show the difference between the deep encrypted population and the standard population. So now I'm in the MongoDB shell, and I've preloaded the IDs so that we can quickly run the queries to show that there are no subjects in either query. I will go back and let's start loading data. We will start by loading data into the standard population to show how the standard population looks in the database. So we're going to select the standard population and go into its screens. I'm going to select the data tab, and the data I'm going to load basically looks like this. This is test data, so we don't have to worry about showing PHI during this presentation, but this is representative of patient data that could be loaded in a CSV form. And so I'm going to manually upload that data. And you can see all of the data showing, and what I'm going to do is configure the basic subject ID and the date, which becomes important later. I will load that data into the population. Now we're loading the data into the HIPAA compliant but not deep encrypted population. Now you can see the data successfully loaded. So what I will do is drop back into the MongoDB shell, and I will query that population. And you can now see that that population has plenty of subjects. You can also see that the data in that population is not encrypted, that it is plain text as stored in the database, which is what a database administrator or support person with a direct account to the database would see when accessing it. And I will further take the internal Apervita identifier and run a second query to get all of that patient's data, replacing the identifier here, as every patient has a unique identifier. And you can see all of the data now loaded, not just the summary data in the database. And again, as you can see, the data itself is not encrypted, so anybody with direct account access would have access to the PHI. So we'll clear these screens so we can load data into our deep encrypted population. So we jump back and now into the deep encrypted population. Again, going to load that same file so we can compare the files. Again, now this patient ID selection is important because that patient ID is the customer's identifier. And again, it could or may not be PHI, but we treat it as PHI anyway. So as we look into the database and the encrypted data, we will call out how that identifier is also encrypted. We'll load that data into the population. And now that we see the population is loaded, I will again drop it into the MongoDB shell to show what that looks like. And so this is the ID, and now we can start to see that the summary data is all encrypted, that with direct account access, I do not have access to the PHI. We can also see that that subject ID, which identifies the patient for the customer, is also encrypted. Now I will take our internal Apervita ID. I will again run the query here. We will see all of the details are now encrypted. And so now someone with direct access to the database, a database administrator, a support person, people who don't need to see the PHI to support the system no longer have access to the PHI. The only way to get access to the PHI is now through the platform, which as an authorized user allows me to go into the encrypted population. And I will go to a preview page, and I will pull that data out of the database, and now it is decrypted to the end user that is authorized to see it. So this is deep encryption in action. What you can see is the data being decrypted because an authorized user has accessed it through the platform. But what you see when you access it through a direct database is encrypted data. This data is encrypted by the MongoDB field level encryption technology, and we have applied that technology to encrypt the data in this particular population with its particular key. If I were to create a second encrypted population and encrypt that data, I would not be able to use the same keys to encrypt each other's population. You have to use the unique key for each population. And so we have applied field level encryption in our deep encryption product to allow access to the PHI only to the appropriate user through the platform. And that concludes our demo. And that also concludes our presentation. I want to thank MongoDB for the opportunity to tell the deep encryption story, and to the field level encryption team for their support during the beta and the implementation. You can find us at apervita.com, and you can look for me in the speaker lounge. Cheers to all.